Well, hi there YouTubers. Hope this finds you well on a rather wet weekend day over here. I'm just having a quick update on, well, not an update, a quick run through of testing my steel on my new Rockwell tester. So the first stage is I'm getting everything ready before I start, and basically what I've done is I've got, that's one batch, 24 pieces of steel. Basically, I've got 12 in 3mm and 12 in 2mm, which is the two most common thicknesses that I use. And the reason I'm doing it on two thicknesses is I've actually been lucky enough to have a chap who's had two of my knives, pretty similar, but one's in 2mm, one's in 3mm. And the feedback I've got is that the 3mm is holding its edge a little bit better. Now there's two possible reasons for that. It's the same steel, the same company that makes the steel, and it's gone through the same processes. Is that using the same heat treatment process for the slightly different thicknesses steel is giving slightly different results, or I might have done something slightly different, so I'm being very careful while I'm doing my testing. And up to press, all I've had is the hardness files, so whilst I've known I've been in the ballpark, I'm not knowing exactly where in the ballpark I am, so I'm hoping that will change. So what I'm doing is I'm doing exactly the same tests on both thicknesses of steel. So normally I would have just run one set of tests, and that's taking it to different heat times and different top heat temperatures and different tempering temperatures in my oven. And then I'm going to test that range of things, varying from actually no temper to different grades of temper to see where I'm at with my oven. So like I say, then hopefully I'll know exactly where I am in the ballpark, not just that I'm in the ballpark. So up to press, like I say, I've cut my pieces of steel out. They've all been numbered, drilled, ready to go on a little rack, so I don't have to do them one at once in and out of the oven. I'm going to do little batches. I'm doing them in batches of 4, which ties in with the actual little tests. The first set are actually in the kiln now. I just got everything ready, put them in the kiln, went for a coffee, came back and realised I'd programmed it and forgot to click start. So anyway, half an hour lost. So it's going to be pretty much all day. Steel going in and out of the kiln and in and out of the oven. And then, like I say, what I'm doing is I'll do the comparative testing. If the steel comes out and it gives me the same Rockwell readings on the same for the same process, then fine, I'll probably leave it at that. However, if I find I'm getting a different Rockwell reading for the 2 and the 3, that means that I'm potentially needing to look at running different cycles and putting the steel in batches. So if I'm heat treating 2mm, I'll just heat treat 2mm, or 3, or 4, or 5, whatever it is that I'm doing. If they come out and everything's the same, and it's just turned that it's obviously the difference is that I did put a slightly different grind on the 2 knives, and it could actually be that. So obviously one maybe has a slightly tougher edge, one more or whatever, but this should tell me that. But like I said, it might just been a slight difference in the heat treat, because one knife I actually made it one of the first ones I finished over a year ago, and it could be that at that time I maybe got it a bit harder, or just that particular thickness of steel with that grind in the way it was done is like one of those. It was a Wednesday afternoon car instead of a Friday afternoon car. Everything just came together. So we'll find out. So I'm going to crack on now. I've got these to finish off. I'd say I did the first batch. These now, although they've been cleaned up to here, I'll just finish them on the grind to make sure they're fully flat, and they'll be polished up to 240 before they go in for the heat treat. Then obviously it's out. Really good clean up. These are not going to get, I'm not messing about putting the ATP on these because they're so small. As they come out, I can just actually grind them. I'll make sure that they'll both get a good grind on both sides before I do the test to remove any possible decarb that might be on there. So, and it tends to only go into a fraction anyway, and I just want to know the thickness of the steel, so that should sort that out. Just like I say, it's just a case of being a little bit more careful, but probably an awful lot easier. So, right, I'm going to crack on and get the grinder going. Oh, nearly forgot to bring you guys with me. So the first step obviously is just warming up the oil. This is my small quench bottle, but small quench pot. So that just obviously gets that temperature up nice and warm. And then we're ready to put the first batch in. Maybe 1 minute, less than 1 minute. Doing this also warms the tongs up, helps to cut down any kind of thermal shock when you're actually doing the blade, so it doesn't do any harm. And sideways, ready, and first batch. In you go. Doesn't take much, not that thick. Not scientific, but just down to burning. Just too hot to handle. Should be spot on. I'm going to get these cleaned off. Get them in the small oven. That's what my gloves are for, which I should have been wearing when I was doing that quencher, but it's not really good, I suppose. Right, now I need these pieces off here. These. There we go. Just put these into my little oven. Sorry, it's just behind you guys. That keeps them nice and warm. Ready for going into the tempering. There we go. Keep that rod for the next batch. Next batch will be going in on too distant. Make sure I'm quenching at the temperature I want. Whoa, there she goes. There we go. This is the 3mm batch, so this will take a little bit, just a little bit longer to cool down. So that should be spot on. There we go. And same again. Get these off here and into the oven. Keep them warm. Now I can give them a quick clean up. And it's into the tempering oven. Oh, spot on. Keep these as warm as I can. Once they're in here, it gives me a bit of time to take a tool pill. So there we go. That's the first cycle done. First batch, 2 more batches to run. They're going to now just get a quick clean up so they don't sting the house. And up into the oven for tempering. One of each will be staying here because that's just one of each. Obviously, we'll check the hardness I'm reaching before temper. And then the rest will be tempered to different gauges to check my oven and check the technique. So there we go. I'll bring you back later. Maybe when I've got the Rockwell going. Back here, guys. If this seems a little bit disjointed, and this will, because it's only appearing in the middle of the video, I was doing some pottering yesterday and I tweaked my bloody back. My old stupid fault. Trying to lift a piece of machinery that weighed about 85 kilos on my own instead of just sitting on my ass and pushing it with my feet. So I just got a bit of a tweak. Luckily it's not too bad. I'm a bit mobile. I managed to crack on a little bit yesterday. So anyway, finishing this off, that little bit of a ramble in the middle of all this seems strange, but basically, like I say, what I did was I'd hardened and tempered the 4 batches of bits of steel, which you've just seen a bit of that, and then literally nothing exciting from there. It was onto the grinder with the old welding magnet and just basically sort of like polishing them up. That again, I just cleaned the slough off, made sure I took the surface off just in case there was any decarb, and then polished them up to a 240, ready for going on the Rockwell. So that's what was done with all the bits and pieces. I did those in batches, and the results here. I mean, quite happy if anybody wants to suddenly take a screenshot and save it all and look at all the bits and pieces I got from that. That's fine. Just remember, there is no saying whatsoever that your kiln will hit the same temperatures as mine or your oven will hit the same temperatures as mine. Because I'm sure on a kiln, you know, bit of testing, you can get it as hard as you can go to the top end or whatever. Just remember, in your own oven, they all peak and trough at different size. So you set your gauge, say you set your gauge at 200C or 400F, whatever. Your oven might reach from the 200, it might reach 2.5 or 210 or 215 before the, whatever it is, it's solenoid or whatever, I'm probably talking shite there, but whatever it is that detects that temperature and then knocks the temperature off, and then what comes, it'll drop down. How far it drops doesn't really matter. It's the top temperature, because the hotter it gets in there, once it gets to that heat and it's into the steel, that's your tempering. You can't change that. The only way you can redo it, if you have your tempering oven too hot, the only way you can get any more hardness back into the steel is to re-harden it. So start low, build up. You can always you know, put the temperature in the oven really low, get a little oven thermometer, see how it comes out. If it's not hard, if it's on, you know, if you're in centigrade, you could add another, say, 10 or 20 degrees depending on what you think, and it's actually not made as much difference as you'd think in my tests. But you can get a bit more softness and toughness into the steel to take that hardness out, but you can't put the hardness back in, so just bear that in mind. So with that, I'm just going to show you, I've got my tests here. I've got a couple of pieces out. The first one I'm going to do is just it was hand and not tempered. The second one is one of the tempering ranges, just to show you what I do on on my Rockwell. So I'll probably cut this out because I'll be walking around like politically incorrect. I'll be walking around like I've shit myself. But anyway, here we go. Okie doke. First one. Check where it's been before. Just there. Move you guys round, and hopefully, as you can see, that's actually just over 65. So that's been hardened and not tempered, and it's just over 65. So, wahey! There we go. Setting the test load. That, and away she goes. God, where'd I put my cup of tea? Beep. And there we go. Tempered at that, and we have 59. I hope that's showing. There we go. That's 59.5. So, turn that round. Pretty pleased. Oh, there we go. Right, I'm back. There we go. Bit disjointed, probably a bit. Sorry about that. But I'm not quite that mobile at the minute. Just put these bits of steel back in the relative blacks. Okay, well. So yeah, so really pleased. Obviously, you know, as lots of people point out, that this is only one part, it's only one element of knife making. I personally think it's a very important point. I know lots of people poo-poo it and things like that, say, oh, you don't need this, you don't need it. And it is all about how your knife performs and what you want from your knife. Because I'm now trying to venture into my back, making knives for other people, I'm just going to pull it in a little bit. You know, it's not just for me. I'm making knives. I want to, you know, to check that what I'm doing is as close as I can get it. And this is really, it's the only way of doing it. That, and then obviously the feedback of the knives in the field. And my feedback's been coming back really well, so I'm really pleased. Because the other part of it isn't just how hard you get the steel, it's the grain structure and the quality and the things that then that gives you the extra little bit when it comes to the edge holding, the edge it will take, and you know, the toughness of it, what it will kind of abuse it will take. It also tells me really quite accurately that, you know, what temperature I need to be tempering at to give me particular characteristics. So whether I want to go for the you know, the 60-61 for small, skinny, hunting type knives, around that, so I might probably around the 60 seems to be quite popular, somewhere around there for some of the chef type knives, or then dropping that down to the, you know, even 57, 58, 56, 57, 58. depending on the size of a tool. If somebody's wanting something like heavier work, a harder use tool, that's got to be tough and withstand a lot of like side pressure. That's why I wanted to do this, and that's the best way of making sure you get that. And what I can say is I'm really pleased in that the results I've got are actually, I don't know what I was expecting, because everything I've done has been within whatever. You can go on Google on lots and lots of sites, and they all give you parameters on tempering different types of steel, hardening and tempering different types of steel. And I've stuck within those parameters. I've done nothing out of any order. I mean, these steel companies have paid millions and millions, you know, to get their processes right. What it has shown me is how to get the best out of that steel and the process and the temperature I need to go to and the holding and things like that. And it has definitely, might have been, I mean, the lowest reading I got on a piece of steel that was hardened and not tempered was 63. And that was actually that was worked up within the parameter, the normal parameters. The top end I got was 65, which is bang on, that's what I was aiming for. And again, that's still within the parameters, so you'll have to work out with your kiln and your processes and things like that, and how long what your ramp speeds are, your holding speeds, you know, how you want to get that. But what it does tell me is that there is no way on this planet I could get these kind of results and this kind of quality of steel doing what I've always done in the past, which is using the torch to heat the steel. Because the difference that I've actually got within, relatively speaking, quite a short difference between the bottom you know, the temperature change between the bottom one and the top one that I used is not big. You're only talking what, 30 degrees, 30 degrees C between the bottom temperature and the top temperature. I worked, I mean, the recommended temperature between 780 and 820. So if you think that you've got a differential there of 40 degrees C between what they recommend is your lowest temperature for hardening steel and the top temperature, you know, you can know you're getting within there somewhere with the old magnet test, which is what I've done for years and turned out perfectly good knives. And if I was doing it just for me, if I was wanting to make knives for me, one of the things I probably wouldn't have purchased, well, the two things I wouldn't have purchased, was the kiln and the Rockwell tester. The grinders and things just make life so much easier, especially at my age, and they just make it just far better. But I can turn a perfectly good knife out for me with my little gas forge, a magnet, and quenching oil, and it's always worked. And I'm going to be doing a bit of testing on some of the stuff I've done in the past just to see how close I've got, but that's just for me. Alright guys, just doing a bit of handle sanding, finishing a couple of blades off, and I thought, you know, I'd just have a little check of something. That's what I put it, have a little check of something. So I've just done that. Now, and it's about, well, you know, people often say it's not just about the Rockwell of the knife. You know, it's about the other properties that the steel has. Well, this is a knife I made approximately 20 years ago, nearly. An old coal Barbie with a bit of a hand pump and things like that. I think I've shown this before. Always been very happy with it. It's always worked well. Takes a good edge, shaving edge, holds it pretty well. You know, I've always it's held it up against, you know, a lot of other things I've had. Recently, I've been testing it against this little knife. I've just made a little Puko I made for myself. Both 01, both British made 01. They're both 4mm. This has a 24 degree bevel. This has a 26 degree bevel. So you'd actually expect this one not to hold up as well. But what I found is that this one actually takes a better edge, which you'd expect, it's 24 degrees, but it takes a better edge. It holds that edge longer, and it's a bit easier to resharpen. Now, all in all, they're probably not far off what you'd expect, slightly different, you know, grind. But it is definitely noticeable in use. So I just thought, well, obviously this one made in the old, the old coal Barbie and things like this. I thought, obviously, well, what's probably happened is it won't have hardened as much as, you know, what I would have used in my in the kiln. And when I've tempered it, it was just in the old kitchen oven, and I had no idea what I was doing. I just slapped it in at whatever it was recommended at, and out she came. And it worked. So it does, it works. However, checking this on my Rockwell tester, This knife came out at 60, bang on 60. This one came out at 59. Now, all things being equal, you would expect the knife at 60 to probably take a slightly better edge, hold it better, on the same materials and things, and be a little bit harder to sharpen because it's harder. But the reality is, not only is this knife sharper, it holds its edge longer, but it's still actually easier to sharpen. I think that's a side-by-side test of two knives I've had, one for a long time, one for the last few months, and it just illustrates to me the difference. It is not just the Rockwell. It's not just the Rockwell that the knife is at. I think in this case they're both all-one steel, both British made, all-one tool steel. The difference is how they were heat treated. This one was ramped at the recommended rate by the steel manufacturers, soaked at the hold temperature, ramped to its autenzitic temperature, soaked, then quenched, then tempered. And yet, despite this being a full degree softer on the Rockwell scale, it takes a better edge, holds that edge longer, and yet is easier to sharpen. And I think that's the big difference between the two techniques. However, don't let that put anybody off, because this, without me having something to test it against, is a bloody good knife. And I've always been very happy with it. And it just goes to show, if this can come out at 60, I got that steel hot enough, at a high enough temperature, quenched it to get a really good hardness scale out of it, probably well up into the 60s, and then tempering it in the oven has given me a Rockwell of 60. And it bloody works. So I think the two things there is, one is it definitely is more about how a knife is heat treated than the Rockwell, but also about, you know, how what it is that you're wanting to do and whether you want to draw the best out of that steel. So that's just a little bit of an aside there, and I'll get off. I'm going to shut up now, and I will say thank you for watching this little vid, and I'm going to note to self, cut all the shite out. So yeah, so like I said, thank you for watching. I hope you found that interesting. It's, you know, I'm really pleased with the results I've got, so I'm a bit like a cat with two tails at the minute. And I will catch you on the next one. Hopefully my back's a bit better and I'm not stuck in my chair. And thank you for watching. Like I say, guys, have a great weekend. Hi to everybody in the UK or anybody else who watches this. Thank you, and hope you know have a good weekend. And I will catch you on the next one.